Now that you know how to find all the different ways that things can happen, we're now going to talk about probability. So you've done probability a lot. It's just now we're going to do probability on steroids. So the probability is the likelihood an event will occur. So that's going to be either between 0 and 1, which translates in percentages as 0% to 100%. There will never be anything over 100%, not in probability anyway. So there's two types of probability. There's theoretical, which is what we typically do, and then there's experimental. Now if it's experimental, that means we're going to look at an experiment. So we're either going to do an experiment or we're going to look at experiments already done, and we're going to use exactly the numbers that came out in the experiment. Whereas theoretical is where we use the object that we know about. Maybe we're talking about a die, and we're saying we know how many even numbers there are, and we know how many sides there are, so we just do that instead of actually rolling the die. Now I would like you to write this following down in your notes, that the probability of an event, so whenever you see this notation, you have a big P, and then the A stands for what event you're looking at, equals the number of outcomes in the event. So how many does it happen if we're talking about the die and an even number, a probability of getting an even number? There are 3 of those. So the top number will be 3. And then the bottom is the total possible outcomes, the number of possible outcomes. So the bottom number on the die is going to be a 6. Now you're used to that one. That was really easy. But now what's going to happen is we're going to have to use combinations and permutations to figure out the top and the bottom. And the numbers are going to be much bigger and much more complex. Now you start out with a fraction when you do probability, but you can always take that fraction, divide it, and get a decimal. And if you need a percent, you just move that decimal over 2 places, and there you go. So we've already talked about the example of rolling a die. So what about page 717, example 2? Now it says you have a CD that has 8 songs on it, and you put it in your CD player. You set the player to play the songs at random. The player plays all 8 songs without repeating any song. So the question A says, what's the probability the songs are played in the same order they're listed on the CD? So we're looking at the probability that they're in the same order. Okay, notice we're talking about the order these songs happen. So here we're going to say that order matters. So if I need to use either permutation or combinations, I'm going to definitely use permutations because order matters. Now on the top is how many ways can these songs be played in the exact order it's listed. There's only one way to happen, that they're played in the exact order they're listed. So on top is going to be a 1. On the bottom is how many different ways can you play 8 songs. So think about it. You have 8 songs, so you have 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Now 8 songs could be played first, and then 7 could be played second, and 6 could be played third, and so on. So we're looking at 8 factorial on the bottom. So when we do this math, it'll be 1 over 8 factorial is 40,320. And so the probability, if we turn that into a decimal, is 0.123400248. Okay, so there's our probability. Now let's look at question B that they have on this one. So question B says, you have 4 favorite songs on the CD. What's the probability that 2 of your favorite songs are played first in any order? So order doesn't matter. So now I'm looking at NCR. Okay, so let's see, you have 4 favorite songs. We're only looking at the first 2 songs being played. So the probability first 2 are favorites. Okay? Now on top is how many ways can your favorite songs, 2 of your favorite songs, be played. So you have 4 favorite songs. How many ways can 2 of them be played? So we're going to look at 4 choose 2. Okay? Again, order doesn't matter, and on the top we're looking at how many ways can 2 of your favorite songs be played. Since you have 4 of them, you have 4 to choose from. So you have 4 to choose from, but you're only playing 2 of them. So how many ways can that happen? And then on the bottom are the total number of ways that all of your songs, all the songs in the CD can be played. There's still 8 songs, but how many ways can 2 of them be played in any order? And so we do the math using your calculators. 6 on top, 28 on bottom. And this gives you 0.214. So the probability is bigger there. All right, So now more examples. So there's 9 students on the math team. You draw their names one by one to determine the order in which they answer questions at a math meet. What's the probability that 3 of the 5 seniors on the team will be chosen last in any order? So in any order means I'm going with NCR, right? Okay, so the probability, it's a probability that 3 of the 5 seniors on the team will be chosen last. All right, so I'm looking at 3 of the 5 seniors. So on top is how many ways out of 5 people can 3 people be chosen. And then on bottom is how many ways out of all of the kids can 3 people be chosen. Okay, so you do your math on that, plug that in your calculator, divide, and you should get 0.119. Okay, another problem. 5 cards are drawn from a standard deck. So remember, a deck has 52 cards. Okay, you're drawing 5 of them. What's the probability the first 2 cards are red? So the probability the first 2 are red. All right, does it matter what order those 2 are in? Like, does it have to be that a bigger red first and a smaller red second? No, order doesn't matter here. So we're looking at NCR. Okay, but now, how many red cards are there? Because on top, remember, how many ways can what we want happen? So half the deck is red. So that leaves me with 26 red cards. So we're going 26 choose 2 for the top. I want to know how many ways can I pick 2 red cards out of all the red cards. On bottom are the total number of ways you can pick 2 cards out of all of the cards. So 52 choose 2. And plugging that in our calculators, doing the math, gives me 0.245. All right, now let's talk experimental. So if you're on page 717 of your book, we're looking at example 3. Now example 3 is about a survey. And in a survey, it asks internet users for their ages. The results are shown in a bar graph. So you have a bunch of people under 21, you have people from 21 to 40, you have people from 41 to 60, 61 to 80, and then over. Find the experimental probability that a randomly selected internet user is at most 20 years old. Okay, so probability at most 20. All right, so on the top is going to be how many people are 20 or under. So it says under 21 on the bar graph. It tells us that there was 1,636 people. So we'll just go with that number because that's under 21, which is 20 or younger. And then on the bottom is the total number of people. So what you have to do is add up all the bars and figure out that there are 12,443 people. So the probability that there's at most 20 is about 0.131 once you do your calculations. Now B says, what's the probability they're at least 41? And that becomes somewhat simple. So at least 41 means 41 and older. So we add up all the bars that are 41 and older. So it's 3,693 plus 491 plus 6, which gives us 4,190 on top. And they're still out of 12,443 people, which when you do the calculations gives us 0.337. And that should have been pretty easy for us. You guys have done these for years. Okay, another example, you have 9th graders must enroll in one math class. The enrollments of the 9th grade students are shown. In the bar graph, find the probability a random chosen student from this 9th grade class is enrolled in consumer math. So consumer math, there are 36 of them out of a total of, so if I take all of these numbers and add them up, it'll be a total of 243. So the probability that they're going to be in consumer math equals 36 over 243, which is 0.148. Now the probability that they are in Algebra 1 or Introductory Algebra, I'm going to look at Algebra 1 is 87. Introductory Algebra is 51. So if I add those together, I get 138 over. Then you add them all up, total again is 243, which gives me 0.568. Now here's a true experiment. You made 15 of 21 free throw attempts. Find the probability that you will make your next free throw. There's no other way to figure out your probability other than looking at the experiment that's already been done. You made 15 out of 21. So the probability that you will make your next shot is going to be 15 out of 21. And any of you baseball players know exactly how this one works.